Application of mycorrhizal fungi for restoration ecosystem of degraded tropical peat swamp forests in Indonesia. Tropical peat swamp forests in Southeast Asia are the large area around the world and support luxuriant growth of peat swamp native tree species. The tropical peatland in Indonesia covered around 47% of tropical peatland in the world and located at low altitudes in the coastal and subcoastal lowlands of Papua 4.6 million hectare area. Sumatra 8.3 million hectare area and Kalimantan 6.8 million hectare area. Their ecosystem are one of the most important because it consists of the carbon-water complex, which is affected by the impact of human and climate change. Currently, those ecosystem has been declining and degrading due to illegal logging, forest fire, forest conversion into agricultural lands, palm oil and rubber tree plantation, and forest plantation estate for pulp trees. Peat swamp forests become low values of forest resource. Some effort should be carried out to address natural regeneration successfully. Indonesian government has designed and realized some newly national program to accelerate restoration and reforestation of degraded peat swamp forests. However, it is not easy to restoration this ecosystem immediately because it is necessary to select and produce the high quality and survival of tree seedling species. In naturally, mykorrhiza support in supplying nutrition to vegetation in various ecosystems, and may play in carbon cycling by accelerated processes of soil healing. The effect mykorrhizas on growth of tree species in tropical peat swamp forests have been less studied. Information on carbon deposits, vegetation structure, and characteristics of peat before revegetation activities will be the baseline. Initial condition to see the effect of revegetation activities on these parameters, which in turn can be known the significance of the reduction in greenhouse gas emissions from revegetation activities. Some scientist and researcher from Ministry of Environment and Forestry in Indonesia nowadays have been developing fundamental riset at two site province in Indonesia. At Kidatan village in South Sumatra, and Tumbang Nasa in central Kalimantan. The objectives is to promoting and enhancing reforestation of peat swamp forest by inducting mykorrhizal, and to advance education relating to sustainable living and forest protection in the communities. In Kidatan village South Sumatra there are some activities. This plot was separated to plant oil plantation 6-hectare area and natural regeneration secondary forest, 4-hectare area 2. Carbon sink measurement. This activity included survey and sample collection, laboratory test, data analysis, and reports. The collection, sample and boundary of research site was done at November 1 to 10, 2018. Prepared nursery. This project was built the nursery at demonstration site. Nearly all materials originated from organic materials. 3. Seedling preparation. Those are conducting several activities such as seed exploration, spread seed, inoculation of mycorrhizas FMA or ECM, weaning seed, and maintenances. Those are species native tree that were already collected, prepared at Bagger 7. For mycorrhizas preparation, some mycorrhizas were already collected, such as FMA, Clomis sp, Gigaspora sp, Antrophospora sp, Acolospora sp, ECM, Chantharellus sp, Boletus sp, Amanita sp, Scleroderma cinnamorans. 5. Pot seedling preparation. This project had developed one types of pot seedling made by bamboo. In central Kalimantan there are some activities. 1. Determination of research site. The approval letter was signed at August 28, 2018. This project has authorities to manage the demonstration site for 5 years duration with the total area about 10 ha. In general, current condition of demonstration plots has been totally burned, and relatively being bears land. 2. Carbon sink measurement. This activity included survey and sample collection, laboratory test, data analysis, and reports. The collection, sample and boundary of research site was done at October 8 to 14, 2018. 3. Prepared nursery, combined by Banjarburu Environment and Forest Research and Development Bureau facilities. This project repaired and built any facilities of nursery made by organic material, i.e. bamboo, rumia etc. 4. Seedling preparation. Those are conducting several activities such as seed exploration, spread seed, inoculation of mycorrhizas, FMA, GCM, weaning seedling, and maintenances. Those are species native tree that were already collected. Carbon sink measurements are carried out on 5 carbon pools, namely 1 above ground, 2 below ground, 3 litter, 4 deadwood and 5 organic soils. The stages of carrying out the activities carried out in the carbon sink measurement activities are as follows. Determination of the location of the measurement plot according to the plant design, measurement of the above-ground carbon stock of the living tree, non-destructive sampling, measurement of understory and litter, destructive sampling, measurement of dead wood carbon stocks, and sampling of peat to be further analyzed in the laboratory so that it can know the value of the carbon content. Output for these project: 1. To provide a nursery with environmental friendly for producing natives tropical peat swamp forest tree seedlings. 2. To establish native tropical peat swamp forests inoculated with mycorrhizal fungi. 3. To provide 2 demonstration plots of plantation tropical peat swamp forests. 4. To establish sustainable wild ectomycorrhizal edible mushroom in 2 demonstration plots. 5. To disseminate restoration technology based on utilization of mycorrhizal fungi in degraded tropical peat swamp forests. Principal activities for Project: 1. Native and diversified species of trees and mushroom are used. 2. No burn for preparing the land. 3. No chemicals in tree planting process. 4. No plastic, using natural materials are used for tree nursery and demonstration sites. It is applicable to new construction. Outcome and benefit: 1. Improvement of reforestation of peat swamp forest by the role of symbiosis between fungi and roots of a living plant. 2. Providing incentive local for local communities to mitigate deforestation. 3. Communities-based reforestation. With application of mycorrhizal fungi for restoration ecosystem of degraded tropical peat swamp forests in Indonesia. We are believed that the great value of peat swamp forests in Indonesia will be sustained.